first one, solving a problem on coordinate geometry, we need to devise a plan. We need to find the coordinates of D and E. How do we get to these 2 points? We know the coordinates of B and C, so we can find the slope of the line BC. Then we can find from here the slope of the line AD, because we know that they are perpendicular, so their slopes multiply to -1. So now we can write the equation of the line AD, because we know its slope and we know a point, the point A. So then we have the equation of the line AD. The line DC has the equation y equals 8. So we can intersect this line with this line and find the point D. Then we can intersect the line AD with line BC, and we can find the point E. That's very well written mathematically. So now, after we have this plan, let's start to work on it. The last question asks to find the area of the trapezium ABCD. We can do this in 2 ways, either using the formula area equals big base plus small base times height divided by 2. So we get 13 plus 3 times 4 divided by 2. Or a more general formula, which we'll apply in the case we don't have polygons that we know formula for the area. Remember, area is a half. And now I start writing the coordinates of the points. Doesn't matter what we start with. Minus 5, 4, 8, 4, 6, 8, 3, 8, and then I need to close the loop. Minus 5, 4. And then we multiply minus 5 times 4, then 8 times 8, 6 times 8, 3 times 4, and take away the product on the other diagonals, and we should end up with the same answer. Please be aware that sometimes when you do this method, you might end up with a negative number, because the direction counts. If you take the direction anti-clockwise as I took it, you'll end up with a negative number. If you take it clockwise, you'll end up with a positive number. So practically, if you end up with a negative number, you remember that you need to take absolute value of this number.